So hello everybody, I guess we can start. Thanks a lot for coming. We are going to talk about Fable today. Fable is a project to compile F# to JavaScript, so it's a way to use functional programming in your web applications, but not only web applications. We'll see that we can also target mobile and also desktop applications. First, the boring part, we are going to talk about me. I'm Alfonso Garcia-Caro. I'm the author of Fable, but I don't have a computer background. Yeah, I can see. Yeah, it's a boring part. I'm sorry. I told you. I'm actually a linguist. I'm also a Japanese speaker. This is kind of a disclaimer, so it seems that it's if I say something really, really stupid, the chances are very high, so please be forgiven. I'm also the creator of Fable, of course. That's the reason I'm here. And I'm co-author of Mastering F#. It's a book edited by PackPub, so if you're interested in F#, of course, I'm going to recommend you to buy this book. And also, I think I know that you are all wondering that, so the parm is natural, okay? It's not. So I'm working on the NSYNC.de. This is a very cool company. We are doing augmented reality stuff, and we are using Fable there. But before talking about Fable, I would like to play a game with you. Do you know this project, the Gamma.net? Mm-hmm. This is a project that's going to change completely the way we interact with data on the web. And we have here a little game. This is a game to guess how the CO2 emissions have changed for a country in the 20th century and until this year. So we have here United Kingdom. What do you think the CO2 emissions have gone up or down? Up. How much? Like at the beginning of the 19th century or higher? Okay, let's select this. Let's see. No, actually, it went down, so they are doing a good job. But the good thing about this is that here we have, this is for normal users, so they have a graph, very beautiful. They can interact with the mouse, they can play with that. But here, power users who know a bit about programming or maybe database manipulation, they have here a language, and they can edit the graph by themselves. So they have direct access to the data. It's not only that the graph and the data are disconnected, they are connected, and power users can use this. So look at this. We have validation. We have here, we have intelligence, and everything is happening on the browser. Let's see another country. I don't know which country. Do you want? Poland? Holland? Okay. Netherlands, actually, right? It's okay, so it was. Oops, Netherlands. Okay, let's go there. What do you think? Up, down? Down? Middle or very, very low? Middle. Okay, let's try to see in the middle. Okay, let's see. No, actually, Netherlands has gone up. But of course, this is relative, so I didn't check the United Kingdom, so we have to check actually what's the starting point. But yeah, it was something like that. So, so this is the Gamma.net. I didn't do this project. It was Thomas Petricek, very great contributor to the F# community. But this project is made with Fable. Okay. These are some kids. There was a contest, this organization, JR Worldwide, which is making a contest for kids to create a startup company, okay? And they created this website to help, they are kids, okay? You can see in the picture. They are just kids. They created this website with interactions, with maps, to help people know where they should recycle their glass. This web page is totally responsive, so you can read it very well from your mobile. They had the help of an adult, but of course it was volunteer work, so it had very limited time. And they won the contest using this web, and the web is made with Fable. This website that was announced today, it's also about recycling and taking care of the environment in IT. by this company. It's called Noir. Sorry, it's in French. But it's also a very nice website. You can have a look. There's video. There's text. Actually, there's some music here. I don't know if you can hear. But this website is also made with Fable. So I've showed you some examples of websites with different themes. The Gamma.net, this website that help kids win a contest. This also a website to help environmental activities in IT. But I want to explain to you why you should be interested in writing JavaScript. Of course, if you are web developers, you have to write the front end part of the web. You have to use JavaScript. But this not only interesting for front end, because JavaScript now runs in many places. And also I like to think of JavaScript not as a language, but as a platform. The same way we are talking about JVM or .NET. They are not just languages. You have maybe the main language in this platform, Java or C#, but you have also other languages. So I want to think of JavaScript as the same. There is a strong competition between the biggest companies like Mozilla or Microsoft or Google to create the fastest JavaScript engine. The best example is V8. V8 is an open source JavaScript engine. It's very fast. Actually, it's the one that motivated the explosion in JavaScript, because JavaScript started to be a very performant language for a scripting language, for a dynamic language. And this engine can be embedded in many places, not only the browser. So that's the reason that now JavaScript runs everywhere. Runs on the web, runs on the mobile, and runs also on desktop with GitHub Electron. And there's also a huge and vibrant community and ecosystem. So this is a very interesting place to be. So not only if you are, maybe you are .NET developers, maybe you are developers for the JVM, but it's also a very interesting place to be, and also opens many professional opportunities. But I'm talking to you about F#, about JavaScript, and if you want to make JavaScript, why not write JavaScript? Why use F# instead? So I guess I'm not going to go into much detail, but I guess you already know that F# is a functional first programming language. And functional programming, we all know all the advantages of functional programming. And one of the things I like from F#, also from it's Microsoft inheritance, that Microsoft always takes very care of the support in editors, in Visual Studio, but F# took that and also expanded to many other editors. So the F# tooling is really, really good, and it has very good support in many editors. So I think this is something very interesting, because you can develop in F# in the Mac, in Linux, using Visual Studio Code, using Emacs, using many editors that the programmers are using. And as a functional programming language, the focus is on immutability and composable functions, and also declarative workflows, using expression instead of statements, using pattern matching instead of just very large chunks of ifs, using a recursive function instead of for loops, okay? So this means that F# is a very nice language to write your code declaratively, the same way that some UI languages like SAML, for example, they help you write your UI declaratively, okay? So, and it's much closer to, for example, when we are writing a diagram, a workflow, or an algorithm, the code that results in F# is much closer to the original idea. F# is a language designed for productivity and correction. For productivity, I think this is very important. It's something that makes F# a very good fit to target JavaScript, because it has some kind of the same spirit of being a language very similar to a scripting language, a language that had a REPL since the very beginning, a language that reduces the distance between your code and the execution, okay? Between programming and seeing the result on a screen. And also correction. I think this is the main difference with JavaScript. JavaScript is a very dynamic language. This can be good sometimes. It can be very, you can have a lot of feeling of freedom, but at the same time, many errors, you don't get them until runtime. F# has a really good compiler, really good type checker, that is not only in compile, it's in design time. At the same time you're writing, it's giving you continuously hints about how to improve your code. These are some of the codes, some of the editors, that support F#, Visual Studio, of course. We have also now light editors like Atom or Visual Studio Code, thanks to the awesome Ionide extension. We also have Emacs. My work colleague uses Emacs, so it's not like it's a hobby or something like that. You can do professional work using Emacs. And recently we have also Rider, which supports F#. And F# can be used for fun, but can be used for profit, as the great Scott says. So I don't know if you know Jet. Yes, in the United States they call unicorn. So very quickly fast rising startup. Last year, Jet was bought by Walmart by $3.3 billion in the largest ever acquisition of an e-commerce company. So I think, yes, F# can be used for profit as well, because Jet uses everything, does all this development in F#. But let's talk about Fable. Fable, first the obvious. Fable is an F# JavaScript compiler. I hope that you already know that by now. One of our main guidelines is to write to output readable code that is also compatible with the new ES 2015 standards. So it means classes, imports, iterables, for example. And also we want to make interop with JavaScript tools and libraries as easy as possible. For example, TypeScript was a good inspiration for us, because even if we are not like JavaScript as just a superset of JavaScript, which is something very good, because you don't get all the gotchas of JavaScript, but we want to make it very easy to interact with JavaScript, and not just to interact with the libraries, to integrate with the whole ecosystem. And we don't want to reinvent the wheel. We don't want to think that we know better and we want to recreate a whole new ecosystem. We want to integrate with the existing solutions that are already working well. And especially we want to reduce the cognitive load, the cognitive overload of the users. I don't know, especially when talking about functional programming, because it seems that we have to know so many things. I don't know about, probably if you're interested about functional programming, you have read a bit about Haskell. Haskell is a read language, of course, but I don't know. It was recently it was a survey in Stack Overflow that said that Haskell was the language most used during the weekends, and everybody was really happy. Haskell is the language most used during the weekends, and I was thinking, what? I don't want to program during the weekends. I want to do other things. I want to be with my family, so I don't want to spend my whole life only reading books about programming. I want to read other books. I want to do other things. I don't want to spend always thinking about monads, about abstractions, about the all complicated mathematical stuff. I just want to do things, okay? And F# for me does this, and I think I want to translate this philosophy also to Fable, okay? So you can use array assistant tools. We have the Fable repo, which done by it's done by NK. It's a very mysterious person. We don't know who he or she is in the F# community that just PR'd this repo. So you can actually see it here. Very simple. First we have just a hello world. We can have more complicated code. Can you see it well? It's so you can play with that. This is the easiest way if you want to give Fable a try, a quick try. You can just go to fable.i repo HTML, and you can just play with it. And this is zero selection. You don't need Silverlight. You don't need Flash. And this is not going to a server. Okay, this is happening everything on the browser. How is it happening? Because Fable has compiled the F# compiler and Fable itself to JavaScript. And you can see here, for example, we are using a factorial recursive function, and we are just converting it to a while loop. So this is the tail call optimization. We have also a Sudoku solver made by my smart guy that created this to solve Sudokus. And you can also see the response here. And you can see that actually the code, the JavaScript code, is really, really readable, okay? So even if you have to debug or you have to modify the JavaScript code, you shouldn't have any problem. So that's our intention. We want to integrate. We integrate with .NET SDK. So with the new .NET SDK, that makes it very easy to. I know that if you have been into development of NetCore, sometimes it's a bit crazy because things are changing very fast. But I'm confident that they're in the right direction, because now you don't depend on Visual Studio for everything. You just have the command line, and with a few commands, you can install templates, you can start a project, and you can run everything very easily. But still, Microsoft has something. There are some things that it doesn't do very well, like managing packets from NuGet. So thanks to that, we have Packet, and we are integrating with Packet to manage also Fable libraries, and also with Yarn to manage the dependency on the JavaScript side. We integrate with Babel. Babel, maybe if you have done some JavaScript development, you know about it. Babel is also a transpiler from modern JavaScript to all JavaScript, or a JavaScript that is compatible with more browsers. Okay, and we are using Babel. That's the reason of the name, Fable. We are using Babel to output the code. Fable just translates the AST, the abstract syntax tree, from the F# source code, and it outputs, it sends it to Babel, and Babel does the code generation. That's the reason that you see such a beautiful code, because Babel is a tool used by so many people, and it works really, really well. So why should we be doing this ourselves? Because this is the beautifulness of the open source world, that we can just integrate with other tools, and we can take advantage of things that are already working well. And of course, we are interested with Webpack. Webpack, maybe also you know about that. It's a bundler, but also has many themes, and one of the most important things that allows you to do is hot reloading. Hot reloading all the themes. This is something very important. It changes completely the way that you develop. Because when you are using a compiled language like a .NET language, you have to wait all the time. Every time that you make a change, you have to recompile. You have to see. We are this better and better. The compile times are down, so it's not that bad. But still, it breaks your workflow. You are just trying to do something. You want to try something very quickly. You want to see how it's looking on the screen, and you want to see it immediately. Okay? Webpack allows you to do that. Let's see an example about that. So here you'll see this simple application made by this guy, Eric Novales. And you have here the README. I sent the GitHub repository so you can download it. And because I already downloaded the dependencies for you, you only have to start Fable. Fable, actually, you'll see now, Fable is it's coming in the project file. We are using also the new project file, and it's coming from it means that you don't have to install it in your computer. It will be pulled by the .NET SDK automatically. Okay, so the only dependency you need is .NET SDK and Node.js, and maybe Yarn as well. You can see here that we have the code. It's very simple. It's a bit longer than 100 lines of code, and it has a very nice effect. You can see below that also the application has already compiled. You see, this is Visual Studio Code with the Ionide extension, and you can see all the things that we have. We have IntelliSense. We have checking on the go. We have also checking for all the reference. We are using the HTML5 context canvas, and you can see in the context here, we have all the IntelliSense for all the API from the browser. So now let's try to have a look on how it looks on the screen, because Webpack gives us a static server, so it's something for fun. Okay, this was done in 1 hour. Okay, but in our workshop about Fable, by a guy who didn't do any JavaScript at all. We can try, for example, you see, it's just saving and recompiling, and the browser is refreshing automatically. And we can have more particles. We can have 2,000 particles. We can stop updating the x-axis, and then we get this, because we are not updating the x-axis anymore. But I'm talking also about the integration with JavaScript. So let's check what could happen if instead of using this, no, first, sorry, because this is video, I have to remember the workflow. This is me making the wrong shortcut again. And let's see how to debug the F# code directly on the browser. Now we are on Chrome, the tools, and you can see that we have the F# code there. We can set a breakpoint. We can check even the types directly in the browser. We can check the value of the variables. As you can see, we can see the particle array. We can investigate each of the particles. And you see the names are very, very similar. There is no name mangling. We can see everything very, very clearly. We can just go through the debugger. So the source maps are not perfect. We have to improve them, but they are there. So you can debug directly F# code in your browser. We can try now to comment out the F# function, and you'll see that now we are importing a function from a JavaScript file. So we have this update particle function. It's now happening from here. We just save again. And nothing's happening. Why? Because the function, the JavaScript function is the same, right? It's doing the same thing. But we can now modify the JavaScript function, and we'll see the changes on screen. Now we are not updating the y-axis. Okay, so we see the changes. This means that you can integrate Fable in your JavaScript project without any hassle. This is integration at the file level. It's not at the project level. Okay, you see that we are importing directly from the file, and now we are using this update iVelocity from the JavaScript file that is coming from the F# file. So these integrations comes both ways. It's coming from F# to JavaScript, from JavaScript to F#, and also from F# to JavaScript. So now you can see that we can update this function in the F# side, and it's making a change also in the JavaScript side. And as you can see, there is no name mangling at all. We can just use the name of the function directly in JavaScript. And just to show a quick example of the good things about the F#, as you can see here, now we are using 20,000 particles, and things start to go very slowly. If you are developing a game, you don't want this, okay? You want the game to still be fast, even if you have to drop some frames. So we have a nice function here, which is called request animation frame. And this function in the browser will only call itself when there is a new frame available. This is very good, so it won't load too much the CPU. But the problem is this function only takes a float, which is the current time. Okay, so now as you can see here, oops, no, sorry for that. So you'll see that right now we are hard coding there, time step. We are hard coding it. So this means that the particles are going to change the same, even if the frames are very far apart. We don't want that. So we are going now to make the function feed itself the last time, and thanks to partial application, we don't have to do any change for that. Just feed the last time directly into the function, just use it to calculate the difference, and now everything goes much smoother, okay? So still we have less frames, of course, because there are too many particles on the screen, but they are not making our game or application slower. This is a cool thing about F#. But it's not only about this. The secret of Fable and the success of Fable has been thanks to its community. We have now several libraries. I hope that in the near future we'll even have more. This very recent, Fable Remoting. This is a library to make HTTP APIs directly just by defining. You just define on the server side, on the Suave, using a Suave server side, you can just define a record with a function, and you can call it directly from your client side, but this is actually you'll have to read the post. I recommend you to that. But this actually an HTTP API happening there. So you can write your HTTP APIs very, very easily. By the way, Fable is not tied to any server at all. Fable is a pure JavaScript, F# to JavaScript compiler. But of course, it plays very well with F# in the backend, and also plays very smoothly with Suave. Very smoothly. I don't know if you get that, because Suave. Okay? So there we also have the templates. For example, to make a Fable and an application using Suave in the backend and Fable in the front end, we have a scaffold here that was also community-driven. And we have also a lot of support from the community and try to give support in GitHub. But there are also other community members that they are very quick to respond. We have also a Github room that is always, most of the times there are people there that they are able to respond to your questions very quickly. And we have also blogs, we have samples, we have tutorials, and you can go to the Awesome Fable repository that there is a list of all the resources, the main resources available for Fable. I think one of the best samples about this idea of not dividing but uniting and conquer, okay? Instead of divide and conquer, we try to unite and conquer. And one of the best examples is one of the most popular libraries for Fable, which is called Fable Elmis. Fable Elmis taking the Elm architecture. So imagine that you can take the Elm architecture, you can use the power and the flexibility of the F# language, and you can just use React components, because React also has a really big community, and there are many components available. You need a calendar, there is it. You need something to manage a complicated layout in your web application. You can go to react.rocks, and it's there. So this is what Fable Elm is doing. I'm not going to go into much detail because there is another talk right after this one that's done by Stefan, and I recommend you to go there because he will explain the Elm architecture better than me. But we are going to see a very quick example also. And this also, I want to show you how easy it is to start developing with Fable. Because we have now with the .NET SDK, we have the templates. Templates, we have some predefined in the .NET SDK. But as you can see here, if you don't have in your computer, you can just download them. You have to, I don't have to do that, but you can do that. And then we can just create a new application. As you can see here, and create it there. You can go to the directory, and you see all the files that are already there. I'm going to go to another one I just created because I already installed the dependencies there, so you don't have to stare at the screen while the dependencies are downloading. But this is the same as you get just by typing .NET Fable, .NET new Fable Elmis React. Okay, again, you have the structures here. We don't have to, we can install the dependencies, but because they are already installed, they will download very quickly. So, except for NuGet, so NuGet is a bit slower as usual. We have this command, .NET Fable npm run start, which is actually, because Fable has two souls, it has the .NET soul, and it has the JavaScript soul with integration with the Webpack and Fable, and they have to communicate, so .NET is going to, the .NET SDK is going to call Fable, the command line tool, and Fable is going to call npm, okay? The npm script, which is going to call also to Webpack development server. Everything can be a bit complicated, but actually it's everything there, so you don't have to worry about that. So now we can, we downloaded our dependencies. We can just run Fable. Again, you can see here, Fable is on the project, so you don't have to install it globally. You can just manage using Packet and also the FS project file. You can manage the exact version that you want to use for a specific project. It means that you have a project and then you have to update Fable for another project. It won't create any conflict, okay? So I think it's something very, very good. So as you can see here, again, Stephen will go into detail, but as you can see here, we have a division between the state, between the types, which is basically the model, and also the messages that are being sent to this update function to update the model. And we have also here this is the view, okay? If you know a bit of React and JSX, this is something very similar, but that we don't need a new language because F# is expressive enough to declare a language. And as you can see here, we are just making, oops, sorry, again. As you can see here, the views are simple functions. So this is the most powerful template language for creating HTML because it's code itself. We can just call a function, and a view can be a function itself, and it's very, very easy to compose. So here we are creating a button with some events, with some styling. As you can see here again, we have IntelliSense for all the styling that we can use with CSS. And also, of course, we have type checking. In this case, we can accept both a number and a string, so it's okay. But, for example, for something like a class name, if we try to feed an integer, it's going to complain. And very quickly, as you can see here, it's complaining immediately. You don't have to wait until compile time. Thanks to the Ionide extension again, and F# compiler, of course. So now we'll go to the browser. We'll have a look, and we have a very simple application that is made. It's a single-page application, so there is navigation, but this navigation is all happening on the front end, and this means that we can store the navigation also in the state. And as you can see here, now we can just make a change, save, and if you see below, this Webpack already detected the change, and it's recompiling, and it's just refreshing our browser automatically. So just imagine that. You are just developing, you are just focused on your editor, and then everything refreshing the browser is taking care for you. We have a very simple function here to update a state, just a counter. This is the classical, this is like a hello world for this kind of Elmis application. So we can change the update function and say, now we want to add 10 every time that we want to press the +1 button. So you see, the change has already happened. But the thing I really like, and the thing that's very important about being able to integrate with JavaScript tools, is that JavaScript now, they have really modern tools for development. They have, of course, this hot reloading thing, but they have also tools like React has an extension for Chrome that lets you see the virtual DOM. Because as you see the functions that we are creating, these are creating a virtual DOM, so it's a bit difficult to see the real DOM sometimes. And thanks to this extension, we can just see the virtual DOM. And as you see again, that everything is matching. So in this case, we have the properties that we are passing to the view, that we can see them also in the browser and debug them in the Chrome DevTools. But there's also another tool, I love it, and it's Redux DevTools. This is called Redux because it was originally for Redux applications, but now you can use it in many places, and also with Fable or with Fable Elmis application. And this is time traveling debugging. So because we are using an immutable state, so every time that we want to update the state, we just send a message to the update function, and we feed the state again to the view functions. We don't have to worry about any mutability in the state. We can just save snapshots every time that we are updating the state, and then we can just replay everything that we've been doing. Imagine what it does for debugging, that some tester is debugging something, it discovers a bug, and then they can just save the steps they've done and send it to the developer. Okay? So you can reproduce exactly what the user did to create the bug. Mm-hmm. And as you can see here, even the navigation is being stored in the state. So we can just go back in time. And as you can see here, just by going back in time, we're undoing the navigation. Okay. Any questions so far? Andrea, you told me that you were going to interrupt me all the time. And okay. You weren't expecting that. Okay. No. So this is a good sign, right? Okay, thanks. Okay, and we have been talking about some projects and that have been done with Fable, but what I want to tell you is that Fable is not only for hobby apps. This already been used in production, okay? This is being used for Noir, this company that created the website I saw at the beginning. It's being used by MSU Solutions. It's being used by Ionide. Ionide is the extension that is being powering the F# development with Visual Studio Code and Atom. That you've seen how easy it is to develop F# in a lightweight editor, like a Visual Studio Code. And this extension is being written F# and compiled to JavaScript because Visual Studio Code extensions have to be written in JavaScript. So this is using Fable as well. Prolocid is a Canadian company. Eugene, the author of Fable Elmis, works there, and they are using Fable as well. And NSYNC, again, my company, we are using Fable as well. Also, there are job offers in Fable. I don't know, I'm not taking, recently I'm very happy in my job, so I'm not taking many job sites, but I'm checking Twitter, and these are job offers that are about Fable. Actually, the first one, I took it myself, so this one is taken, but the other one is very, the other one is very recent, and I don't actually know what happened. I hope that somebody took it, and yeah, so you can see that the companies are already trusting F# and Fable to do their web apps. But I'm telling you reasons that the companies are using Fable, reasons that why you should use Fable, but maybe you're interested also in why I wrote Fable, okay? So this is not out of hate of JavaScript, that sometimes when we write a language to compile to JavaScript is because we think, no, JavaScript sucks, it's really terrible. I actually like JavaScript, but I like F# more, okay? I like the tools, I like the community. I think it's a very, very productive language. I think you can do functional programming without having to think all the time of staking monads or transducer or things like this. The editor helps a lot. At the beginning, I was using Visual Studio, but then I discovered Visual Studio Code and Ionide, and it was really, really wonderful experience. So I started more or less F# and web development at the same time. I was thinking to ways to combine both of them. I discovered FunScript at the time. I was contributing to FunScript. But then there were some developments like F# compiler services to read and parse the F# source code. And there were also Fable, which could do the same. So I thought that it would be very nice to combine both of them, just putting something in between, and make F# compile to JavaScript. So this happened like 1.5 years ago. I started in December 2015. There were like 3 crazy months of development. Then I released a very proto version with multiple bugs. But it had a very good welcome from the community, and very many people gave me feedback, and they were very happy to use it. Thomas Pertisek created the Gamma.net with one of the first versions of Fable. We were releasing very quickly. I was getting feedback from people, contribution. We were releasing 0.x versions very quickly. And last couple of months, we released the beta version of Fable 1.0. Mm-hmm. This has been a really incredible journey for me. It's been not only the development of Fable itself, but meeting new people, being a member of the F# community, which is a community I really love, and also being invited to places like this, like incredible conferences like NDC. But all journeys must have a goal, and the goal of all software products is to release stable versions. And for Fable, this happened today. And I'm really happy you didn't need the hint. So, if you are interested in Fable, we'll be having the FableConf. Fable is something more familiar, much smaller than NDC, of course. This will be the first time that the Fable community is going to gather on the same roof in Bordeaux. This call, we were thinking of using Fable conf name, or maybe cheese, wine, and functional programming, which is what we are in the intention we have to do, actually. So if you want to come, you are more than invited. You can get your ticket. It's very, very cheap. It's just to cover the venue and the meal, which is going to be a very good French meal, I promise. And you can use the discount code only for this week, so you need to be quick and not think very much. This is NDC Oslo. And that's all for me. Thanks a lot for listening. I hope that you enjoyed a lot of the conference. And if you have questions, I'm more than happy to take them. And of course, if you want to bore me when I'm around, I'm also very happy. So I don't know if you have any questions. I can also show some code because I was just writing writing the video because to avoid problems during the presentation. But if you want, I can show you a demo, for example, for React Native if you're interested. Or I don't know. I'm open. I'm expecting. I finished faster because I was expecting Andreas interruption, but Andreas is not interrupting.
You promised some flamenco dancing, which I really need to see. I mean, you promised me, so.
But in my head, this was happening at the beginning in the sound test. Now I think it doesn't fit very well. Do you think?
Well, I don't know. I think we should let Andrew see this.
Okay. Flamenco is very serious. Okay, yeah, sorry. Henrik. Very good. We have, I have to admit that this Fable remoting library is very recent, so I didn't try myself very much. But we have this Fable powerpack, and this is... sorry. So the question was if we can show an example about using HTTP requests and how it works with promises and async. So if you know a bit of F#, in F# you usually have async, which is more or less similar to task in C#. And but in F#, in JavaScript, they have promises. So you can choose with Fable, you can choose either to use async. We are compatible with async. By the way, we are not compatible with the whole VCL. That you can see here. You can go to the docs, and you can see here all the types that we are supporting. Okay, so this is also very important because we don't want to embed any runtime. We don't want to put a lot of code in your application. So we are our politics is that you have to pay only what you need. So we are using ES 2015 models. This means that we can use 3 seconds. This means that when you are using your app for production, if you want to minify, you get rid of everything that you don't need. So here you can see in the documentations, for example, we are trying to be as performant as possible. So when possible, we just use the native JavaScript type. But at the same time, we are keeping the .NET semantics. So for example, you can use regular expressions, you can use datetime, but you'll get the same results as in C# or .NET, sorry. Please don't accuse me of making the equivalence of C# and .NET. Okay, so if you go to Fable repository, you can go to the test. And you can see here, for example, you have the date time. And these tests, we have now more than 1,200. These are run every time that we make a commit. These are run for JavaScript and .NET. So we are sure that the same semantics is being kept. And of course, we have async that Henry was asking about. But because async works a bit different to JavaScript promises, you may want to use promises directly. With async, you have like a wrapper. So in some cases, you may prefer to use promises directly. For example, when using the Fetch API in the new Fetch API for some browsers that it's working actually very nice. We have this Fable powerpack. And here, I think I have to. Yeah. And here you can see that we have also a computation expression for promises. So it means that you can use more or less the same syntax using something like a await, for example, for promises in JavaScript as well. This means JavaScript, for example, now they want to add support for promises, but they have to add it directly in the core language. So again, you have to wait until Babel accepts it. You have to wait until the browsers accept them. But with F#, we can define our custom computation expression, so we don't have to wait until the language changes. We can do the changes by ourselves with just a library. So I hope this answers your question, Henrik. But here we have examples for using fetch in Fable powerpack. So here, for example, is an example of how to download a web page. We just here you can see we just want to get the length of our web page. We just feed the URL, and then we get it. We have two options. We can use either the computation expression. So we have this syntax like here. Or we can just use railways programming, so just more similar to LINQ, for example, just to link lambdas, to chain lambdas. And you can see here as well how easy it is to make parallel requests. We can just add promise parallel, and then we get the results in an array. Again, here we can we get a result with we can catch the exception, or we can use actually I think it was here. Yeah, we can use try fetch, and try fetch will return a result type, which means that it's forcing us to check if the request was successful or not. So this is the way that we can use the fetch. The fetch API is an browser API, so it's not something from Fable. The Fable powerpack, the only thing that it does is just to provide a very simple way to, an idiomatic way to handle them in JavaScript, in F#, sorry. But it means that you are not just bringing a huge library only for convenience. It's just you are using directly the API from the browser, so it's more performant than having your own library, because the browser are implementing C++ and they are really performant. But at the same time, you can use all the benefits of the clean F# syntax. So here, for example, you can see how are you using the computation expression for promises. So you see everything here for and return. Everything here is happening asynchronously, but we can treat it as if it were synchronous code. So I hope this answers your question. It's okay? So I don't know if anybody else has any other question, anything we want to see. Maybe because, yeah.
I wonder, the JavaScript portions of Fable are written in F# and then compiled through Fable, or did you just write throughout JavaScript?
First, I started, so we have this Fable Core library, which is more or less the replacement for F# Core. So when possible, we try to inline code, and we try to use the native counterparts, so it's more performant. So for example, for arrays, we just use JavaScript arrays. But then we have also a Fable Core for things that they are not provided by JavaScript native libraries. And this is written first in JavaScript, then we move to TypeScript, and then now, because we are improving the Fable workflow, we are going to start writing the Fable Core code in F# itself, and then compiling to JavaScript. Actually, a couple of models. For example, we can use big integers in using Fable. This was and the maps and the sets. They were written in F# and then compiled to JavaScript using Fable. but it was done ahead of time. So it means that if you go to the repository, you'll see. So for example, map. So yeah, all this stuff. This actually is coming. I took it from FunScript, which actually what's taking it from the F# core itself. So yeah, in this case, for the map, F# map or F# set, we are just taking more or less the same code as in the F# core library, and then compile it to JavaScript. But you can see here, this is the Fable Core library. Mm-hmm. Have everything here. So now you have any other questions? Maybe we have time for the React Native? I don't know. It's taking a risk. Live coding. I just did it right before coming to Oslo after midnight, so it can be a really, really big fail. The main problem is that, okay, it's a React Native. I'm going to use Fuse. So you know Fuse? Actually, Fuse is being developed here in Oslo. It's another tool, a similar tool to create mobile applications using JavaScript. And I'm going to use it because with React Native, I have to start the Android emulator. It's a bit slow, so maybe you can get bored. So let's go for... and I think here... These bindings were created by Dave Thomas, who was playing with Fuse. I didn't know Fuse before. I have played only a little bit. It's a very interesting tool. It's just a tool. It's more focused on designers because you have this SAM-like markup language that is using. Yeah, it's doing most of the UI stuff. And then, for example, in this very very simple example, the logic is really small. You can see here just less than 50 lines of code. But it's really interesting because it works very fast. So you have again, you have here the instructions. You just have to install the Fuse tools. You have to clone the project. You have to install the dependencies. And then, again, just call Fable and run an npm script. In this case, because, oops, where am I? Okay. In this case, because we have two tools, we have the Fuse and we have the Fable compiler, so we have to use two different terminals, one for Fuse and the other for Fable compiler, but still we have the same hot reloading experience. And this is mobile, okay? This is going to... Now you're going to see iOS emulator. This is always in the presentation. So it's happening fast. Okay, good. So you can see here it's a very simple application. As most of the things are being defined in the XML, like the UX language, they call it, this markup language. But we can still define some things. This is being used more than the React Native, which is using more like this Elm architecture. Here we are using observables, so it's closer to this functional reactive programming paradigm. We can, if you have a look here, we have finished home screen. Then we can focus again on this. We are using also Webpack here, so we can save. This already happening, and you can see here how fast it is that it's already updated. And this is an iPhone emulator. It seems that it means that you can do Android and iOS applications also very easily using Fable. Go to NDC. Again, you have it here. So it's also a really good way, a really nice workflow for your mobile or web apps. Anything else? We have 5 minutes. 5 minutes. Sorry? So basically, it's some just some bindings. So the way that we, for example, you were seeing this the context, the Canvas API that we have IntelliSense. We are taking the JavaScript declaration files and we are converting them. We are translating them to F#, and then we can just use them to give the IntelliSense and everything. But then we have some metadata that will convert these calls to import expressions in JavaScript. So it means that in JavaScript, in the JavaScript bundle, this code instead of going to F# is going to call actually the actual JavaScript library. But you don't even need this. So in this case, you can see it here. So as you can see here, this partly automated and partly manually edited. But then we can have just interfaces, and then we tell where these interfaces should be imported from. And this is what it's going to be transmitted to Webpack, and Webpack will know where to get the models from. And then sometimes when we have to, sometimes we want to have something in a special method in F#, but it actually has to be translated, so something different in JavaScript. We can just emit JavaScript code directly. And also, again, in the documentation, you can see the ways to interact with JavaScript. You can even use dynamic programming, so you don't have to. If you don't have these bindings, these declaration files, you can still pull a JavaScript file and then just interact dynamically with it. You can just define simple interfaces to interact in a more type-safe way with foreign libraries. You can use these special attributes like emit or like the import attribute here, or also import expression. So you can just, actually in the previous example, you just saw that we were importing this update particle function. We're just importing directly from the JavaScript file. If you don't know, this is the new ECMAScript 6 2015 modules. So they work with the imports and exports. So they are fixing one of the biggest problems in JavaScript, that they didn't have models. So people had to do many hacks to create these models in JavaScript and avoid that everything was global. Okay. And you can see also here how can we call F# code from JavaScript. We have also things like helpers for JSON serialization. And Zaid also wrote an article to explain other ways to interact with JavaScript from Fable. So you can see it. Again, this is a bit outdated. We have to, because this is the previous version of Fable, which had actually a command line tool, but now we are interacting with Webpack, so it's a bit different. But yeah, now that we just finally released the stable version, we can focus on the documentation and the samples. By the way, you have already a lot of samples here. You have very funny games. You have also React applications that directly using React, for example, with Elmis, and doing testing. You can have visualization here using, for example, this is 3JS, which is a tool to do 3D graphics in the web. And you have all the code is commented here using F# formatting. By the way, I didn't show you the Fable Elmis side, which is really nice. And it's made with Elmis itself. It's they're still changing a bit the styling, so it's going to change probably. But you have also samples here, and the docs also are very good. You can go to different libraries also within Elmis, and you can see how can you interact with Elmis. So if that's all, I think we can finish here. And of course, I'd be more than happy to answer any question that you can have. Just grab me there when I'm trying to take a coffee or just anything. Or hit me in Twitter or in GitHub in the Fable compiler. Just we are in the Google 8, so just Fable compiler or Alfonso Garcia-Caro, and you'll get me. I cannot escape. So thanks a lot for coming, and I hope you enjoy the rest of the conference.